Hello, and welcome to AV Cyberactive. Many web applications accept input from either external data sources or from application users. In this course, we'll discuss the types of injection attacks, such as SQL injection commands. I'll also cover how malicious users submit malicious code or commands to web applications for execution of web server stack. Next, I'll discuss how to test a web application for injection vulnerabilities using OWASP Zap tool. Next, I'll set the low security for vulnerable web application tool in order to allow the execution of injection attacks. I will then execute various types of other injection attacks such as web application. And lastly, I will cover how to mitigate injection attacks using techniques such as input validation and input sanitization. Item A03 in the OWASP top 10 for 2021 relates to injection attacks. Injection attacks really result from malicious input that is provided into an application. That input is accepted often without properly checking that was supplied to the application is valid. So with a malicious user input, we are talking about something as in this scenario. On the left, we have an attacker. The attacker supplies malicious input. That could be done in a variety of ways. For example, it could be in a form of a web form or a web page, and there's a field that would not properly validate or sanitize it. And so the attacker puts in some executable and scripting code in the field and gets executed on the web application server. So the web application then wouldn't properly be validating or sanitizing the user input. And those two items, validate and sanitize, they are not the same. They're just synonyms. Validating user input meaning that making sure that something that was put in, for example, that the 6-digit that was put in instead of 6 letters, but we don't modify the input with validation. We just check it. We validate it. Sanitizing can actually modify what was the input, such as removing special characters or removing quotation marks or semicolons from input, whatever the case might be. Now, the injection attacks can stem from problems or a compromised user station. So, client-side application types of attacks, what runs on the browser, and often in many applications. Client-side, if it's allowed, it can be turned off in its JavaScript. So we have malicious JavaScript code that runs on a compromised machine that then crafts a malicious user of some kind or sends the data with malicious code embedded with the web server, or it could result from a browser extension that was installed on the client computer. Sometimes this can happen without the user's knowledge, and they have installed a browser extension. They might have downloaded some free software in the background. It might have installed some kind of a browser extension or plugin that might even be malicious. And interception attack, which is also called on-path or man-in-the-middle attack, MITM for short, occurs when an attacker that positions themselves in the communication between the client and the server. They can intercept traffic, and depending on the nature of the traffic on the application, they might be able to make modification to the traffic and then send it to the victim. So they might be able to intercept the request before it gets to the server and then send the modified version to the server. And there's a lot of different ways that can be executed. One of which is an attacker can somehow get the private network and enable something like an ARP cache to poison all the devices in the network, which would basically instruct them to send anything going out of the router first, going through the machine, so everything would be visible to the attacker. Now, another type of VM escape is the virtual machine escape attack. Generally speaking, if a virtual machine is compromised, it is difficult for an attacker to back out of that to the underlying hypervisor operating system running on the virtual machine. It's remotely possible, but it's remote. And of course, we know that there is a server-side application like forged certificates, cryptographic downgrades. HTTP interception can be considered a server-side attack if it's perhaps capturing something sent from the server to the client as a response. We will also know that the server side can include poor error handling in a programming level, which might disclose sensitive information such as the version of web application stack running on the server side, which then makes it easier for the attackers to find the vulnerability in the version of the web stack server. We don't really want to disclose the type of thing, so saying that we have an injection attack, there are possible, it's very generic. There are a couple of common like cross-site scripting attacks. Basically the attacker injects executable code and then run by some victim's computer. There's also a header injection. The header are normally used when one physical or one virtual machine running on the web stack server, but you want multiple websites on it with different DNS domain names. So the browser on the client side would then send the host information when it talks to the web server, so it's connected to the correct web application when we are hosting many one of them on the server. So depending on how the host header is used by the backend, application code will determine whether or not an application attack is possible. There's operating system command injection, which does what it says. If there's a vulnerability in the application, and there are many different types of vulnerabilities, this might allow this to occur and allow the attacker to run commands on the server side in the operating system, and they would run in the context of the user account that the web server stack is running with. When you run a web server, it runs with the permission to a service account of some kind. And of course, we have got this classic SQL database injection where promptly validated field can allow the attacker to inject SQL statements that runs server side and backend database and return more information that was intended by the developer. So with the SQL injection attack, the attacker might enter something like user ID 123 or 1 equals 1. This in the form, let's say, on a web form where the user can search for something, and that's where they would enter into the user ID field. Now, the thing about this is that the SQL statement that we put together on the server side might look like a select from users. User is in the table where user ID equals 123 or 1 equals 1. So only one of those things might be true or not both. One will always be equal to 1. That's always true. And if this isn't properly validated and protected, it's possible that every row in that underlying user's table would then be returned. And that strange thing about this is that this type of injection attack, a SQL injection, has been around for quite a long time, and in some cases it still works. I know it's hard to believe, but that's the case. The key thing to remember here is that all this applied into a web application must be treated as an untrusted or hostile, which means that you must validate and sanitize it. Do not trust anything. Techniques such as fuzzing, input validation, and sanitization are great measures to ensure that our application is secure and stable, doesn't disclose too much information, and doesn't accept malicious user input. Let's go into more detail. Really, the idea is that we should trust no one. The concept of zero trust means that even an internal network, let's say you've got an intranet with web application that serves as line of business application only to employees, even then you should not trust the user input from internal employees, nor should you trust their devices, because those user devices could become compromised with malware of some kind. So the zero trust notion is important to begin with. It might sound a little paranoid, but there's a good reason for this. And this day and age, so many web application attacks are so prevalent at the time, so that means that we should apply security hardening techniques to reduce the surface attack to internal and external users and devices. So don't have more trust on internal employees using company supplied devices inside the network. Reducing the attack surface is hardening. What this means is that we have a number of things that we can do to make things more secure, such as adhering to secure policies, code, and guidelines, which means only allocating good enough memory for expected input when it comes to memory variables. Now, and only up-to-date components should be used. So So trusted components are those which software developers will use and call upon with their application instead of reacting to little things from scratch. For example, there might be a trusted component that allows GPS location required for your application. So instead of developers or softwares writing that code from the scratch, they might use an existing component or the library that is already in use. Many organizations do this, a lot of custom software builds, so that we have trusted repositories through deep testing which has been acquired, and those have been placed in private repository accessible to software developers to those items. That could also include the trusted of launching new virtual machines or software development testing or an internal container image. Hardening or reducing the attack surface also means applying updates to operating systems, to web server stacks, to applications or any components to that application's use. But in order for you to do that thoroughly, you need to know what's out there. You need to have an inventory of all the different operating systems that's out there, the application systems running on them, the components that are being used by applications. If you don't know what you have, you can't protect it. So reducing the attack surface also means that disabling unnecessary services, disabling user accounts that you don't need, disabling unnecessary components, especially additional functional modules. Maybe they are running within the web server stack and they are simply not ever going to be like PHP listening module. When it comes to testing the security web application, one technique is fuzzing. When fuzzing, what we are going to do is going to use the tools that design this, and that sends randomized or malformed data into the application. Now the reason I want to do this is because attackers might do this type of thing, and we want to observe how the application responds. Watch for the behavior. Watch for the memory leaks and the sensitive data disclosure. If they are handled an error exceptions and might disclose too much information, or the server or certain thread side that is hanging on the application. And also for the fuzzing to truly be effective, give it a true picture of stability and the security of an application. It needs to be conducted for a long period of time, not just for 1 or 2 minutes, but over a period of time. That's when you will see the memory leaks happening, and this should be done periodically. Now there are all kind of tools available out there like Burp Intruder, a Peach Fuzzer on downside. Even the OWASP Z proxy attack can be used for fuzzing. Now this is an important tool to add in your toolbox as a web developer or as a security specialist. Now we had mentioned input validation, input sanitization, where input validation checks to see what was submitted as acceptable. It doesn't change anything. Sanitization does. For example, we've got an SQL real escape string built-in function. This is a MySQL function. It is not specific to OWASP or anything like that, but what it's designed to do is to improve unnecessary characters from input related to MySQL queries. So we are accepting user input. We are going to sanitize it by removing things like single quotation marks or the dangerous characters that might be intercepted by query engine. So we are removing these items so that they are not passed in the query engine. But of course, input sanitization, validation, and fuzzing are not the end of the story. They are very, very important, but that's not all you should be doing. So what else you can do to mitigate injection attacks? Well, we know what we should be doing. We should be validating, sanitizing user supplied input, and we should treat all user inputs being malicious, even the internal devices used by employees. Now, doing this input validation and sanitization can be done on the client side, such as JavaScript in a web browser environment or server side. You might use client side validation just to make sure that some fields are required aren't left empty. But they are real code that does the real validation, and sanitization should always be by the server side, so it's not visible on the client side as a code. As a web developer, you cannot control everything running on the user device, and so it could be compromised, thus revealing your input validation sanitization code. But what happens is that you have a lot more control over server side, at least when it comes to web application admin. So that's why the bulk of the user input validation normally happens on the server side. What else we can do to mitigate the injection attacks? We can use a web application firewall, or WAF. This is the hardware or software appliance, and its purpose is to look for web application attacks like injection attacks. It looks for those type of things. So not only it can prevent these type of attacks from getting into the web application, but it can also be configured to report these potential web application injection incidents to alert administrators that this type of thing is happening. In this demonstration, I'm going to be testing for injection attack vulnerabilities, and remember there are a couple of different types of injection attacks. Standards would include things like injection, command injection, or a SQL injection. Well, I can use the OWASP ZAP tool to do this, to test for vulnerabilities. ZAP stands for Z Attack Proxy. So the OWASP ZAP tool can be a proxy whereby between a web server client and a web server, and examines the traffic for testing purposes. But I can also launch a vulnerability scan against a web application given a DNS name or an IP address using this tool, and it will tell me if it discovers vulnerabilities, including injection vulnerabilities. So we can download the ZAP tool for Windows or Linux, or for the Mac operating system for free. Now what we are going to be running the ZAP tool against is the Metasploitable 2 virtual machine. Metasploitable 2, if you recall, is a free download virtual machine where you can set the severity to be low, and you can test various types of vulnerabilities, including injection and vulnerabilities. I've installed the OWASP ZAP. So from the start menu, I'm going to launch the tool. Now once it loads up, I'm going to minimize it for a second because I've got my Metasploitable intentionally vulnerable application virtual machine is up and running, and it's running, in my case it's 192.168.4.124. Here it is. Now what I'm going to do is going to run into DVWA, so that's damn vulnerable web application, and I'll log into the admin and password of the password because I want to go into DVWA security item. Currently by default the virtual machine is set to high security, which means it's not vulnerable. But what I'm going to do is, in this case, is set to low, and I submitted reflected over here. It says security level is currently low. Excellent. Now we can run a scan against it, and we are going to get the results for testing purposes. Results about vulnerabilities in the web application. Now here in the OWASP ZAP tool, if you have previously ran into vulnerability scan against a web application, now you can go ahead and open it up. If you have saved it by going to file and open session, what you would do here to save it, and you would have to select a persistent session. So if I go open here, I can go ahead and, for example, you can open up anything I've saved. There are many items when you might run into in the background because it can take a while, and then save it in the analyzer at some future point. Just don't go waiting too long. You might want to make sure you analyze it quickly as possible to identify the vulnerabilities. But to run a new scan, what I can here is I can go ahead and click in automated scan. I can fill, in this case, the IP address or the host name if I've configured it correctly, and I can determine if I want to use spidering or go to crawl, basically to discover and test the vulnerabilities using examples like for Firefox headers, which means the GUI, but the backend engine, or in my case I can choose Chrome headless. Now at this point I'm ready to go, and that's really all you have to do if I want to directly scan web application for vulnerabilities. Now these kind of tools like OWASP, ZAP, and Burp Suite, not only they can do what they were talking about, but web application scanning, and also add as a proxy as well, so you can monitor traffic from web browser. For example, through this tool you can on its way for the web application and go back, as you can also watch what's happening with those requests and responses, even make modifications, send it back on the wire, that type of thing. We are just scanning the web application, so I'm going to go ahead and click on the attack. Now immediately on the spider item we can see testing connectivity. It's learning about all the web pages that are available in the web application, in this case 192.168.4.124. and it's running. We'll be able to see the alerts to see if there's any automated or problematic issues that we need to focus our attention on. So at this point of time, I'm just going to go ahead and wait for that to run, depending on the application, how large it is and how many pages it has been and so on. This might take 2 to 3 minutes, and you can go on to the active scan tab over in OWASP tool and see whether or not it's completed. You see the percentile here. Now it's already completed over here, so you can go and save this. You can go to file, or you can choose to the persistent sessions, so you can open up at any point of time and you can analyze it. So at this point of time, if it clicks alerts, I have the full listing of the result that is encountered. Now we are interested primarily in the red flags. Those all alerts some kind of high severity, whether it's an injection attack or anything like that. So for example, cross-site scripting attack persistence, or otherwise called stored attack. If we open that up, we can see the URLs we are connected to determine whether or not it's a problem, and it looks like that was actually sent, and we see a full JavaScript alert message. And if that succeeded, and that's why it showed up here as being a problem. Also, it talks about cross-site scripting attack, and also the idea being we need to make sure that we are validating and sanitizing the input. Now over here, you would see the right on side, the OWASP Zap tool. I can see a list of what I've actually sent to that, and again, that's kind of like a summary of what given down below in JavaScript alert function. So by selecting these things, we can get some details about what kind of vulnerabilities were found within our web application. So if I further go down below, I will see the external redirector errors, path traversal errors. Now I see these errors as well because usually it really means that it's a weakness. It's a vulnerability that was found within the application. Now that's all very important because we need to focus our energy on solving these problems, hardening these issues. In other words, closing the loop, making sure these vulnerabilities are no longer vulnerabilities at all. Now we have got our remote operating system injection. That's another problem. As we go further down, server side include SQL injection attack problems, so we know what to focus on or to harden our application. And remember, it specifically is giving me the URL, so I know which pages we really need to focus on. The OWASP top 10 for 2021 item A03 injection. Injection attacks essentially means that the malicious user can input some data on the server side code running on the server that isn't properly been validated or isn't sanitized. In other words, not removing special characters could potentially allow the malicious user to supply data to the server that the server will then execute, then returning information that otherwise that should not be disclosed. So in this case, we're going to focus on SQL injection attack for the backend SQL server. In my web server, I'll be navigating to the IP address for my MITRE exploitable 2 virtual machine, which I have been running on my host, and I'm going to run down to and click on the DVWA link. I'm going to sign in over here. It tells me at the bottom the admin and the password of password. What I'm interested here in doing the SQL injection over here in the left, where I can submit user IDs on the server, and it will search through the SQL database and it will run a SQL query to retrieve information for the user ID that we specify here. Okay, well, that sounds good and could be useful. So if I could enter the user ID of 2 and then click submit. Okay, apparently user ID 2 is Gordon Brown, and if I enter it 4, Pablo Picasso, and if I enter 7, then there will be nobody. If I enter 5, it's Bob Smiths. Okay, so it's allowing us to enter user ID. It's passing on the server, and the server is running the query, shows the user information. Now if I click on the DVWA security link on the left, currently the server for the script on the server it's set to low, and now we have chosen between low, medium and high severity. Low allows to test the users on the application, whereas high would switch to high script for all these attacks, where the high script means that the security is properly put in place for if the attack will to be failed. So let's see what it means here. We're going to have to leave it to low. We're going to go to the SQL injection in the user ID field. I'm going to run in 1 = 1. and each of these ones are enclosed in the single quotes, but when I press enter, it doesn't like the syntax, but it's telling me that I'm running a SQL server. From a malicious user standpoint, that's narrowing down to the focus of the vulnerability on looking for MySQL. We don't really have the version string, but we know that it's a MySQL, so running the backend, testing for database. Okay, let's test this bit over here. I'm going to put in one space or space, and then quote another space, and then an equal. So I'm going to tell it here that I'm testing the backend database engine. So if it will accept a query where we will look for either one or equals, which always evaluates to being true. Let's see what happens. I'm going to click submit. Look at this, it's returning everything in the backend database because querying for one or equals one is always true, and this is telling me that there's no proper input validation on the server side. It's just letting the user type whatever we please into the user ID and is using it as a part of SQL query. It's not even sanitizing the input, looking for special characters like codes and removing them or anything like that. So it's not escaping any weird characters that might we might provide. So let's explore some file system web pages that might compromise on the meta-exploitable web page. So here's meta-exploitable Linux virtual machine. I'm going to change the directory to something that like www.dvwa vulnerability SQLi for SQL injection. Okay, so I'm going to go to the source directory where we have got high, low, and medium PHP file, so we can change the security on the web interface. It's switching to one of these scripts and is what becomes index PHP here. Okay, so let's go back into the source, and what I find to do is load.php file, pipe it into more. All right, what's happening here? Let's look at what's got ID variable over here. We've got the ID, and then that ID is simply being used as a part of the SQL select statement, where it's selecting the first name in column, last name column, and table called users, where the user ID equals whatever we put in the field. Nothing is being checked, no input validation, no escaping of weird characters. This is not good. However, if we were to cat and high PHP and pipe that to more, we'd get our ID variable where we retrieve the ID from the ID field of that form, but then it strip slashes function is being called, and then our ID that we've entered. Okay, that's good. Then there's the MySQL built-in function called the MySQL real escape string is being executed, and we are passing it to our ID variable. Excellent. We have got some sanitization being done here, then some validation. If is numeric ID, so if it's numeric value, because the user ID is numeric, then we're going to the query. We're going to run the SQL statement along with the ID, and it continues on through the loop getting into the query. So then we switch between high security as a part of the website. It will now simply let us put whatever we want in the field and have that run on the server side. So let's get back on the web application. Let's go DVWS security on the server side. Let's switch to a high security, use script and submit. We will know that the script. Let's go back to SQL injection. Let's try again, one or equals, and then submit. We get 0 because we are properly validating and sanitizing the input server side before simply executing the SQL query. We're going to look at yet another example of an injection attack. In this item A03 of the OWASP Top 10 2021. So you've got your things like in SQL injection attacks, where you've got improperly validated user input from the user that is fed into the query that returns insensitive information that shouldn't be returned. But in this case, we're going to look at a command injection attack. In other words, we want to somehow manipulate the web server into executing the commands of our choice. So let's flip over to the meta-exploitable 2 virtual machine. I've got the web application running, so I've connected to it, and I'm going to click on DVWA on the left, and I'm going to sign in as an admin with the password being password. What I'm interested in is clicking on the left of this example of this command execution. So we have got a sample web page here that show us a ping for free. Now we have got to enter the IP address, and then server will do it for us. We are going to ping here from the machine that we issue in this form. It's going to happen in the server side. So if I ping the Google DNS, that let's say 8.8.8.8, okay, after a moment we have got some return output where the server has pinged the IP address, and we have got echo return. This did not happen on the local machine where I'm typing in this happened on the server side perspective. From a malicious user standpoint, it would make me wonder what else will let me execute when we are typing into. Is the field validated? Is it being checked for what type of data is being supplied? Really, it should allow an IP address, but what are the limits? So let's say I'm going to go into ping something else like its own loopback address, IPv4. The loopback address is to test your IP stack for 127.0.0.0.1. But the thing is, in the Linux environment line command, you can separate multiple commands with semicolon. So here we could then try another command like lsl and alongside listing, and let's say of the root directory, just slash. In this field is this field validated properly? It's simply going to take all this and execute it, and then the Linux can have a bunch of statements strung together with semicolons. Well, this is good. It says error and you've entered an invalid IP. This is what we want. The field is being checked. That is where the meta-exploitable configuration, if I click dbw on the left when the security was set too high, that is good. This is how it really should be in production. Now let's examine what would happen if I set the security to low, which changes the website to a low security application version. So submit back the execution on the left, and in the field 127.0.0.1 lsl long listing of root directory, submit. Well, what do you know? Not only did it ping the loopback IP, but below is an output of LSL, a long listing directory of root directory. Now, I have a listing of files and directories at the root of the file system of the web server that ran this command and returned the output of my web server. This is a big problem here. In the Linux and command line on the web server, it's already navigated to var www dbwa vulnerabilities for this intentionally vulnerable web application. We are using this only for testing purposes. If I do as in here, I got a subdirectory called exec for command execution, so I'm going to change the directory to exec and clear the screen for ls index.php. This is currently set up here. I will depend on whatever we have set, high, medium, low. So if I go and change the directory into source location here and do an ls, this is what we have got, the high, low, medium security pages for this particular exploitable message. So if I were to cat low php, here we have got php page that runs server side where an HTTP post is being submitted on the web server, where the requesting IP address, that's the IP address that we can ping on that example web page, and it's actually then running the shell exec php function to a run command to like ping, and we are now passing the target. The target is simply means whatever we have typed into the field, and then we are returning that result into the command into the HTML page, so nothing has been checked. The user supplied input could contain anything, so it's going to try to ping, which means it could run into a magnitude of commands here in Linux, whereas if we clear the screen and cat php file, let's scroll back up and take a peek of what's happening in the particular case. Okay, so we still have the same construct over here, php. For submitting the HTTP post, we have got the target variable requesting the IP, but then it's using the PHP strip / function to remove any slashes that might be present on the user, might be validated. So first, that's a good first step. Then we have got a comment in PHP comment, or at least the single line comment that prefixed with 2 slashes. So check if each octet and IP is an integer. So it's now doing and calling upon the numeric function. Now we have got an octet variable that is established above the exploding apart from IP address by separating each chunk based on the dot delimiter, and of course there's a dot between each of the 4 parts of IPv4 address. And we're checking each one on the array. So the first time the item is 0, and the next time is 1, item 2, item 3. It starts counting at 0. We are checking each one to make sure they are numeric, and we are making sure that the size of the octet variables that we have for items, for parts of the IP address, no more, no less. Then if we are all integers, we are putting it back together. The target variable is putting back each one of those 4 items, octet item 0, 1, 2, and 3. And then of course it continues to actually executing the command, pinging the target IP, generating some HTML, and then returning back to the browser. So this would be one way to check properly that what was supplied to the field and is what is required, which is an IPv4 address, 4 octets long, each separated by a period, nothing less, nothing more. Now, many web applications use some data from JavaScript or JavaScript in the client side or in the server side code. So on the server side, web application components will be using Java, and on the client side, they would be using Java applets, which are some compiled Java programs that are designed to be embedded in a client side application. For example, you could embed Java application within HTML. You could also use JavaScript code if you wanted to run the client side, maybe to perform some kind of validation or supplied unit input. But what that's not only thing that can be used for, it's a language and it has a wide array of possibilities. Let's start with focusing on the Java itself. So Java is not a scripting language. It's not interpreted like Java, but instead it's compiled. You compile a Java language, Java program. Java is also cross-platform, so you can run Java programs on a Mac OS or Linux host or a Windows machine, but in order to do so, you need the underlying supporting environment, Java runtime, or JRE for short, which is normally instead separately installed from the Java program itself. Now, of course, on the web server side attack, you might install a Java server applet servlet gateway, which allows small programs to run the server. Small programs that are written in Java that run server side attacks called Java servlets. On the client, as we say, they are called Java applets. Now we know that the Java applets can be embedded within HTML and therefore run on the client. And we know that the Java programs in the form of applets can run client side, but more complex Java programs can be run server side. As an example of what Java code might look like, and its case is sensitive as well. It'll look like very familiar that you have programmed in variations of C programming language over the years. The first thing to do is import the required libraries. Here we are importing Java util scanner so that we can take some user input from the user, and we are declaring class call hello world, and the next thing we are going to do is to read user input by initializing and creating new instance of scanner class. Now we want the system input, and then we are going to send out a message. The system out print and displays on the screen, tells the user enter your age and years. Next thing we do is to read into an integer variable, int, an integer name and variable that we are creating here is called user age. It'll store the result in reader.next initialized. We are calling on that method. Now what we are going to do is print out the user on the server, and except this time we are going to print a line, the print ln, where we will tell just the text we want to display back, and we are concentrating plus the sign variable here. So while this is only a partially code example, really what's not happening here's at least the code is in the segment. We are not validating or sanitizing user input. Now, mind you that all this is happening in the back with the print line statement, but it's not being checked on the other side. So they with Java, we've got a programming language that runs client side, usually on a web browser environment. You can embed Java using script tag directly within HTML documents. So the idea that it gives that you have way more functionality than you would otherwise have only in HTML. Remember that HTML is really a markup language and how to display that format data. If you want to be more sophisticated program task, then you're going to loop in or working with arrays and variables and so on, then you need to be using something like JavaScript. But the thing is that the JavaScript is like Java is case sensitive. So an example of Java code here, we have got an HTML document where you're using the script tag and setting it type to text slash JavaScript. Now within the opening script tag where we have the closing script tag, we don't see it yet. So that's where you would see the JavaScript syntax. Here we are creating a function called show message, and what we're doing are calling upon the built-in part function of JavaScript, and we are simply displaying back a message that says hello world. Now in most web browsers that will simply pop as a dialog message if JavaScript is allowed on the website, and then we have our closing script tag embedded within the HTML. The closing script tag has a front slash in front of it, and then it would have the rest of our HTML document. All we have done so far is to declare the function that it's not been invoked. So in the body of the HTML document, that button is being displayed the web page. Input type equals button is going to say okay. One click event on the button is going to execute our JavaScript so message function if you defined up above. So that's how it would appear embedded within the HTML. And then we have got another variation JavaScript, so to speak, called the node.js. So this is the JavaScript where the JS comes from, but the idea here is not considered to be running only within the web browser, but as being embedded in the HTML document. So node is normally used in the server-side code. Doesn't have to do, but often it is, and normally it is a .js function. So node is just another way, the server side choice that you might select if you want to do things like generate dynamic web page content, or to do file management server side, or read and write back in databases. Let's take a quick look up another example of a node.js code. Here we have a variable called http. As we go down further, we will really be doing and defining a function where in the end it is going to write back the text hello world when we get to a connection to this machine to port 8081. So if you've got Node.js support internally installed locally, for example on a developer station, if this file was called hello world.js, you would invoke it at the command line with node space and then the name of the file hello world.js. Another fairly common website attack would be cross-site scripting, otherwise called an XSS attack. Luckily, this one of those attacks that can be dealt with in web application firewall. However, it still boils down to the proper source code guidelines, and at the end of the day, so what happens at the cross-site scripting is that the attacker on one way or the another, and we'll discuss about other methods, will inject malicious code onto a vulnerable website. Okay, so how was that done? Well, normally it's done with the JavaScript, because the JavaScript would be malicious code and would be executed on the client computer. Now you might wonder how that's possible when the attacker is injecting the JavaScript malicious code on the server. Well, let's take it a step further, because there are various ways they get the malicious code into the web application. One would be through a web form, and it's not the only way, but you might have fields in the web form that the user might sign in using guestbook, or to enter a search term or something like that. Or in the fields, you've got something like multiple web forms that aren't validated, sanitized properly. So in other words, if you are not checking the special characters and not validating that, if you're checking for credit card number that was applied, that the user might inject some script. Now that also happens through a URL depending on the web application. Some web applications would allow incoming URL through the web server with additional parameters and values, and that might be on another way that executable code in form of JavaScript is sent to the server. Or it could be even be an API call. A malicious attacker might have a component that makes an API call to a server, and the API server side might not even be a published commercial type of API. That could be a custom API designed just for this web application, but the API might accept input from another network that would not validate and sanitize the supplied input. So what would be another way that could happen? So in the end, really, it's about improper input validation and not being careful or not treating input as hostile. So all the user needs to be treated as untrusted. With all stored cross-site scripting attack, what happens if that the malicious code onto a website? So maybe it's a web form, they put some JavaScript, and so maybe and the web form fields don't detect it, and that the code gets stored in the server. So in step 2, the website visitor would view the page where the JavaScript is embedded. Perhaps the attacker injected malicious JavaScript that doesn't result in anything in the user interface. It just runs in the background on the client victim computer of their web browser. So what could it do? Well, what would JavaScript do in any web browser session? Usually it's a sandbox so that of the browser tab, but it can also do things with the sessions, perhaps even manipulate cookies. There are few dependencies on whether it's possible or not, or read other objects that is available in that memory space for web browser instance. So the cross-site scripting attack victim would then unknowingly execute the code, and that is what is called the stored or persistent cross-site scripting, because it's stored on the server side. It's persistent between reboots or visits, different visits from the different victims, so to speak. So attackers might even have the ability to steal the web browser session cookies because the JavaScript that might be in control. Now running a client web browser session, they might even be able to impersonate the user session, that might be able to log keystrokes, turn on the webcam. The sky's the limit. This JavaScript is a programmable language. Here we have a screenshot of injecting JavaScript into a web form of the field. Specifically in a screenshot, the second field is called message, and instead of typing the message, it looks like embedded JavaScript. Here the opening and closing tags are being used to embed in the HTML. Now something along the lines, but not exactly the same, in another type of attack, cross-site script forgery, or CSRF in short. That's how it works. In step 1, we would have the user, that is an unauthenticated session, would with a legitimate application like a banking site. So the user will legitimately authenticate to have a valid session. In step 2, while the user is still logged on to a banking website with the valid session, so it hasn't been timed or anything like that. One way or the another, users tricked to visiting the fake website. So maybe the fake URL link that they're fooled to clicking onto, where the link is an ad that looks like they might be interested in, but really that is not a legitimate ad. One way or the another, user might be redirected to the malicious URL elsewhere. Then this was bring some code into their browser. In step 3, the user would unknowingly send instructions to, in this case, a legitimate online banking session using the authenticated session, because the attacker would have the code and would take advantage of the already authenticated session and would perform actions unknown to the user. So in the next screenshot, we have OWASP Zap tool, which can be used to scan for application vulnerabilities. It can be used for application fuzzing. Here it's been scanning for vulnerabilities, and it's found an unsecured cookie problem. In our screenshot on the bottom left, we highlighted the cookie no HTTP flag, which this means that only HTTP only property has been set for the cookie. When you set the HTTP only property for a true for a cookie, it means that the cookie has been sent over the network to an HTTP server. It is not accessible locally to JavaScript code using the JavaScript document.cookie method, using the JavaScript document.cookie syntax. In this demonstration, I'm going to execute a cross-site scripting or an XSS attack through a web page form. Now with XSS scripting, there are a few variations how the attack can actually be executed. As now usually is the case with these any type of DKs, significantly specifically what I'm going to be doing is submitting a stored or persistent XSS attack. Now a stored or persistent attack is such that because it means that the attacker somehow has injected the malicious code that is stored in the server, hence it is persistent. And the way it is going to work, this is particular example is that the attacker will take advantage of an input form. So also a web form with a field that has not been properly validated where they can inject JavaScript. The JavaScript doesn't not run on the server side, but it can be stored in the server side so that others will put that web page that JavaScript can execute in the client's web server. And if you have done any work with JavaScript, you'll be aware that it can be quite powerful when it comes to things like cookie manipulation and doing things like local web browser instance. Luckily, these days, many web forms or browsers they have kept the new and updated patch and our sandbox so that just in case the breakout of the web browser you would be able to get underlying operating system, at least not that easily. It's possible here on that the metasploitable 2 web page, my secure insecure web application, I'm going to run dvwa on the left hand side and then admin with password and password. Now notice on the left the menu there where we're going to focus the XSS reflected attacks are a little bit different, and the idea is that the user is somehow tricked on the clicking on the link, and the link itself is targeted to a different website that is designed to attack or somehow compromise. So in this case, it's going to be XSS stored on. I'll click on that, and I've got a web page that we're here with 2 fields. Imagine this might be on some kind of a web forum, on a blogging site of some kind of where people might submit information. They could submit their name and some kind of a message. In this case, it's signing up for a guest book type of an application. So for the name, maybe I'll specify something like C Blackwell, and for the message I would normally type in the message that they would want to include while signing into guestbook. However, if the message field is not properly validated, the malicious user might be able to inject scripting code like JavaScript if it is for stored XSS attack. It would be stored on the server side so that when the others would come and view the guestbook, it will look particularly entry, and the JavaScript simply executes on the machine. With the JavaScript being embedded in the HTML, we use script opening tags, so embedded within it and a GT sign, and then we have the closing wedge, which pretty much really much the same, except it got slash in the front with the word script, and whatever the code they wanted to get executed in between, this is where you put your JavaScript script. It might be just a little bit too simple, but this could be very long and complex, and in this case I'm all going to run the alert function which displays the message, and I'll have it say hello there. Close the parentheses, semicolon. Normally the attackers would do something a little more covert. Instead of displaying the message, it might alert the user with something happening on the client machine. It might do something like a background activity indication of visually appealing. Maybe it'll do manipulation of cookies in the background of the user's browser machine or something like that. In case I'm going to sign the guestbook, okay, so immediately it executes it and says hello there, but let's click OK. So we've got the new entry over here, and of course the message isn't filled to really look like appear benign. The message malicious actor would normally add a message itself, but we will click here something else and then come back to the page later. The JavaScript executes immediately. JavaScript executes in the client browser. It does not run server side. Java itself runs the server side and active server pages in the PHP and all the server code. It does runs in the Java browser side. So for the attacks that are trying to target something on the client side, either directly or indirectly, such as the reflected XSS, can be particularly worrisome. Here are some file systems that might be metasploitable Linux virtual machine. I've already gone to var dvw vulnerabilities. If I go to ls, we've got 2 XSS subdirectories are reflected, and the other is for _s is restored, which is what we want to look at. Change directory XSS clear, and we all have our file structure over here. It is intentionally vulnerable web application that we have kept the index.php. So depending on the security level of the application will determine what the exactly how it will look like, but that comes from the source folder, where it usually would be the high, low, or medium.php file. So if you've got the website security high, PHP becomes index PHP and active one. So alternately, we are looking at low security, that becomes then index PHP. So cat low PHP. Okay, so we've got the message variable, and the name over here corresponds to 2-digit field form, and they are being trimmed over here, which means to remove leading and trailing extra spaces. Okay, that's a good idea. Now we've got a comment over here to sanitize the message. So it is going to be our message variable, which refers to the message field, and it's running strip slashes PHP function. We pass the dollar message. It's also a SQL real escape string function. Again, we pass it the dollar message variable. And that's good, but not complete. We'll see in a moment here. Then the name field and variable which references the field is also being sanitized. All of that is good, and of course the query at the time of the SQL database injection using the insert into syntax, where the comment of the field names and the underlying table is being filled with values from dollar message, dollar name, variable. Okay, and that's good. And however, let's cat into PHP 1. What's different one over here is the HTML special characters PHP function that is being used, and we are passing our dollar message variable to remove the special characters, that is the GT semicolon, the IT signs, which are required to be embedded in JavaScript tag within the HTML. Right, so back here in the web browser, let's try it out. Let's go to DVW security. Let's see the security count is high. Submit. Go to XSS store. Let's try it again. See Blackwell, and I'll put the exact same JavaScript I did it before. I'll click on this get signed book. We'll notice that the difference is down here. Instead of embedding the JavaScript, so it would actually execute as was the case in the first example. In this case, instead of having the actual less than sign for the opening script tag, the HTML special characters PHP function has instead converted that into IT and the less than respectively. Instead of a greater than symbol, we have got an and GT for greater than, and that is not treated as embedded executable JavaScript within HTML. In this demonstration is all about how to hijack web browser session for an active user, and then there are many things that we can do through the type of connection. We would display whatever is running on the web camera, play a sound on the remote machine, and check the plugins of the browser, perhaps depending on what we have installed on the machine and how unpatched it is. Perhaps even more, browse the remote files on the machine, so we can compromise the web browser using the cross-site scripting attack, basically tricking the users into following a link and clicking on the link that hooks to the web browser and makes it available for a centralized command center to speak, where attackers can issue these commands against hooked in the web browser. So to do this, we are going to be using the BEF tool. Again, BEF tool is a short for browser exploitation framework, where now I've got my Linux machine that happens to be Kali Linux. It could be any distribution of Linux really, because it's the newest version of Kali. Don't seem to have a BEF tool installed. So from the command prompt in the server, the first thing I'm going to always do is run the sudo apt update and make sure all the package repositories on the machine points are up to date, so that when we issue the command of something else, it's checking the latest locations. And we could go do the sudo apt install, and in this case the package itself is a BEF XSS, and I'll press enter. So we got already installed over here. I've already done this to save some time, but if you haven't, you can just press Y and it will allow to perform the installation. Now normally you would do this on a machine and we'll start the BEF service automatically. What I could do to forced to run the sudo command, it runs with an elevated root permission. Now I could tell this to run the bef xss with g.h parameter. Now here it says something already is using port 3000, that is by default port number, so it binds to, so it just shows how the bef daemon is up and running. Let's just flip it back terminal window and for a second, so we loaded the bef service, and now if we go back to web page, and automatically opens up and going to the port 3000 UI/authentication. I'm going to run this on my Windows 10 computer in my Microsoft Edge, where there's more support for running these type of vulnerabilities. So here is a web browser window. I can connect the IP where we are running the bef service. So what we need to do essentially is to trick the user into visiting the URL. The URL is pointing to the IP of our bef server, port 3000, hook.js, JavaScript that could also hit over the 3000 UI panel at the site. And if you're prompted to sign into the bef username and password, it would normally be bef and username, and the password would normally be password, but you might be prompted to change it during the installation. Either way, once you have signed in, you can click the basic demo page link, and here it says the browser is now hooked to the bef console. Now any malicious user that wants to try to control the hook browser would do it by connecting to port 3000/UI panel. It's switched URL for me, so if I sign in with the bef credential, it takes me to the screen where I left, and I have the line of online browser that has been hooked as well as offline. So if I click on any of the online browsers, it will have all of the capabilities shown over here on the right, which includes things like such as host names, IP addresses, and so on, even the screen resolution, so that the window size of the height of the browser, the number of CPUs, type of CPU, GPU information. In this case, it's telling us that it's a Windows 10 computer, 64-bit, so there's a lot of details here. The long tab shows me the activity related to the victim's web browser being hooked. So if I go to the network tab, it can give me a quick information for where the machine might exist over the network. So you've got our hook browser shown here, connected to bef on the same machine. If I click on the commands tab, here is a list of the categories or different types of commands for the machine that I've selected. The machine on the left is hooked to the hijacked computer web browser. Now remember that this happens on one or the other way. We are tricking somebody into executing the hook JavaScript. At the end of the day, the best mitigation against this type of would be security training, and of course limiting the devices that we can get the network, and having strong firewalls, all of that stuff. So this machine is hooked. I am going to open up the command recovery browser category, and then just for fun, we don't have to play a sound. We could specify the URL and port number, as well as the WAV file that you want to play on the target machine. And what we actually do is execute it, and then execute button from the right hand corner. Now we see that the issues commands, we'll get something like a module history, and if we click on this, we'll get the output over here. It tells me that the sound we played on the remote machine. Same thing goes over the things like webcam. If you would want to try to trick the user and clicking something else allows remote access to the webcam, we can have this big information about the website, and then using Adobe Pop Flash up, you would probably seen in the internet a lot that these fake websites don't look legitimate, and then they need Adobe Flash to be installed. So I could change the details for you, but if I want to go ahead and click on execute, it's been sent as compromised web browser, and this is the type of thing you would see. So it's just the way to trick the users into enabling things into web browsers directory. Now there's all kinds of different categories of modules that you can run. The one that are green are most likely would work on the target system. If it's red, it won't. If it's orange, it might. Usually the gray ones are, that means they have no support. So if I want to detect a pop-up blocker, you can go ahead and click on the execute over here, and then after a moment, it might have to take a moment to get back the results. You won't want to take out the results of the comment. Apparently the pop-up blocker is enabled in the machine, so it's set to the value as true. If I go down the host on the left, I could even do a geolocation get where physically get the hijack browser. So I could choose one of the APIs available on the internet, and I could click execute. So not only will we have the information about the compromised web browser that we have hijacked, not only we can do things like that to trick people, but enabling features, but we can also pinpoint where they are geographically. So, and if I click on the result on that one, I will have see the details over here right inside in the browser. Now of course the user is running anonymous browser, so the network VPN solution, then this might not be accurate, but it's a good starting point. I could even choose to get internal IP, not just specific public IP being reported over the internet, which usually is the public IP of the internet facing the NAT router. So if I look at the result in the command 1, if I get the command will execute and give me enough time, you will get to see the results. Notice that this is the orange and it may not work. So if I go here, let's say to the miscellaneous category, if I were able to choose the JavaScript here, it wants to run the JavaScript and it will pop up on the machine. Maybe I'll have it say hello there. So this is what we are seeing, the victim's machine, and of course it would be much more sophisticated than this, but at this point in time we are invoking JavaScript remotely. This is that is executing the in a compromised client web browser. I'll just click OK and accept the message. Back in the bev tool control panel, the command we have just sent and the result worked okay. If the user sign in is into a Gmail, we could attempt to read the Gmail messages. So the list goes on, and would be interesting things that you might do against a compromised web browser. So this is one of the reasons why absolutely paramount that the web browsers should be kept up to date. The users must periodically, take security training, and you need to have a strong firewalls in place to detect this kind of network encryption is placed or not, that you have some kind of security incident monitoring solution in place as well. This is one of those type of security issues that can be indirectly be affecting your security in web applications that you might be hosting. All it takes is one client computer where the website is hosted to be compromised in order for your website to be compromised, and that's why it's such a big deal. So in this course, we've examined how to recognize and mitigate web application attacks. We did this by exploring how to recognize injection attacks and how fuzzing, input validation, and sanitization can be used to protect a web application. We tested for vulnerabilities using the OWASP Zap tool, as well as executing SQL injection on a command execution attack. We then discussed Java and JavaScript in web applications. We talked about how XSS attacks work, and we ran XSS command through a web form in a browser. And so in our next course, we're going to move on to explore how design of web application includes business requirement and related security controls.